Hi, and welcome to our webinar on scaling your AI. We're going to present to you today ML-driven Customer 360 using Neo4j. I'm Nathan Greenhut, our head of accounts for HopsWorks. I have with me today Yogesh Palreka, who is our head of solutions here at HopsWorks. Yogesh is going to walk you through how to make better predictions and accelerate your AI process to get models into production that much quicker.
Thank you, Nate. Hi, this is Yogesh. Hi, everyone. So let me get to the next slide. Okay, so we are going to talk about, how HopsWorks as an AI platform really is helping, other enterprises in terms of implementing their use cases and building the applications. So as you guys know, AI is being used in every application more or less these days, including the new generation, which is Gen AI. So HopsWorks is a feature store platform, or it's a complete AI/ML platform, which allows enterprises to build their applications using Python as one of the API, and also through the low code accelerator, and is helping like our customers to build applications in a very short time frame and make better and accurate prediction making applications. So without the HopsWorks, so I'm just going to compare like how things can be managed with and without HopsWorks, like how people are, how enterprises are actually building the applications. So when you don't have a centralized platform or something which is more enterprise platform for building your ML applications, there are multiple teams who are actually building AI models, and they work in silos, right? They have their own sandboxes or notebooks using Jupyter or something like that, and they may be working physically on different servers too. They could be connecting to different data lakes, data warehouses. So it depends on the maturity of the organization, that how they are managing the data and the application they are building on the top of it. But typically, in the absence of a centralized ML platform, what would happen is application teams are going to build their applications using within their workspaces. And then the engineering team has to, the business users are going to build the models. And then the engineering team has to take those models or the scripts and then kind of stitch them together and bring all the various applications onto a single platform. That could be very overwhelming, because now they not only have to deal with users who are not consistently using one platform, but also there could be inconsistency in terms of how they are using the features. There could be a feature which can have a feature which may have different definitions within different teams, and that can lead to inconsistency. So HopsWorks is a modular platform, and it's pretty robust. It's going to allow you to build your applications all on a single platform, build your features, train your model, and do the inferences. And there are various type of applications that you see here, including the custom analytics or risk analytics or fraud analytics, that can be all built using a single platform. So the problem, what we are trying to solve is really, it's a multifold thing. It's not trying to attack one thing, but I think there are a variety of things that can really become a bottleneck in terms of your application development, or in terms of pushing your applications into production. So, it's possible that if you're not using a centralized platform with a centralized feature store, you may end up building multiple models which are using similar features, and they are being defined more than once, and which can then lead to inconsistency and inaccuracy in your predictions. So that's the very first problem that we have observed with our clients, and that's where HopsWorks really comes into play. It's going to help you manage your features in one place, define them consistently, and be able to use across multiple applications. Again, when you're building everything from scratch, there is a possibility that different teams are using different libraries for the same thing, and they may something could be very suboptimal, which may not lead to a better performance. But if you're using HopsWorks platform, we are taking care of it, because we are bundling these libraries on a single platform, and that way across the organization, every data scientist or the application team is using the same set of libraries, and then there is consistency across. That brings a lot of governance as well, because in the absence of a platform, there could be a chaotic situation, and that can lead into not only inaccuracies into the model, but it can also slow down your process to build your application and take them to production. So by using a singular platform and having all the everybody collaborate on a unified platform, that really helps in terms of doing things efficiently, and also having consistency in your feature data, in your accurate predictions, and also making sure you are able to ship your applications to production much faster. So it's all about, making AI better, faster, and cheaper. That's the goal for every organization, and that's where exactly HubSpot comes into play. So I mentioned about the centralized feature store. I mentioned about the low-code aspect of it. So what really happens is all of these features that are, which I'm going to demo you today from the HubSpot platform, is going to help you in terms of achieving a better, building like an application in a better way, and then also making your predictions more accurate. The time to deployment is a key thing, because with AI applications, as you know, that you don't want to build something that takes like, months and months, and then you're not able to actually identify how good your predictions are. So you want a platform that can really accelerate your process of building the AI applications, and then, from months to weeks. So we kind of help you to do all of this probably in few weeks. I would say 2 to 3 weeks. You can literally build the features and build applications on the top of it. And then once you build these applications, you want to make sure that you're not going back to square one to reinvent the wheel in terms of the performance, right? You want to build applications on a platform where scalability comes out of the box. So that's going to improve your time to delivery, and it's going to lower your TCO, because now you can use that, those funds to build more applications rather than wasting on, few applications at a higher price. So, and then there are features around performance monitoring, tuning, logging, etc. Anything that's required for an enterprise to, manage their AI applications. All of these features are inbuilt. So everything that's required from an instrumentation perspective, that's available on the platform. You don't have to build this feature separately. I think your focus is really on making sure you understand the business use case, the business problem, and do the feature engineering and train and get the inferences out of it. Coming to the performance, we have done some benchmarking. These are industry benchmarks, and there are links to the benchmark here. You can feel free to click these links and take a look at it, how these benchmarks were performed, what we compared against. And as per the comparison results, as you can see, there are two mode of, executing your models here. There is one is online and another is offline. So your feature data you can access in online, and within online, obviously, when you do things online, you want a millisecond latency, right? You don't want to do seconds or minutes. So we have benchmark with our competitors, which is clear here, like, it's 10 to 12x speed that we are providing when it comes to online reads, and when it comes to offline read writes, it's in the range of 7 to 9x. So depending upon which operation you're performing. So this is really going to help you focus on more on building your applications, and also make sure that your applications are scaling as you are building them along. This is a high-level functional architecture of the platform, where you can see HopSux is a platform which contains like multiple components. So one of the component is the collaborative UI, which allows multiple users to log in, or multiple application teams to log in into the UI and build their features, do their training, inferences, and so on. So all of this can be achieved through a user interface, but if they would like to use Python APIs, they can do that as well. If they are comfortable using Jupyter notebooks, then they may be using Python as their first choice. But if they want to come to the platform and start building these things, or kind of administrating or monitoring, all of this can be done through the UI. So we have a UI layer which is internally using the same APIs, and these are the same APIs that you can also use within your application. Now, these APIs are kind of sitting on the top of your feature store. And the feature store, as I mentioned before, you have two areas. One is online, another is offline. That's more to do with what your application needs are. Like if you need something in millisecond response time, you want to hit the online store. But if you're trying to predict something in a batch mode, then you're going to hit the offline mode. There are different type of applications you can build. As you can see here, it's one single platform which can scale, like it's almost like unlimited scale, because we use a horizontal scaling. And there is also a cross-region replication feature available, which allows you to different teams in different geographical regions, they can build their features and push into the feature store. And those features are then kind of available across multiple teams who are spread across different regions. So replication is a feature which is available in the enterprise version. It's a part of the platform. It comes out of the box. So you don't have to worry about managing different ML platforms and then kind of syncing all those features and doing all the ETL stuff. All of this is kind of baked in into the platform itself. So you can literally build any application using this platform, and I'm talking about the AI applications. And today we are going to focus upon customer 360-degree. So we are going to show you one of the application that was built using that is built using HopsWorks. I'm going to show you all the features that are and the capability that are available. Also, we are going to show you a low-code accelerator that allows you to see allows you to build applications with minimal coding. This is a data flow architecture. So if you see, you can have different data sources within your organization. You can have your traditional sources, which is like operational system. You can have data receiving in the form of files. It could be in data lake, data warehousing. We can even read. So we have connectors inbuilt, which allows you to connect to these data sources and pull in your data. Once you bring the data in, you can do the feature engineering using the platform. And then once the feature engineering is done, you can train the model and do the predictions. So all of this can be, if your data sources are available to connect, you can achieve this in like 3 to 4 weeks, and you can go to production on this platform in 4 weeks, literally. And then you have various applications that can consume the inferences that are happening on the platform through the API layer. So we have an API for real time. We have a batch mode too. So depending upon the need of the application, you can pick one of the integration option and then go ahead with it. So, so in today's demo, we are going to look at the customer 360-degree process flow. So I thought before we jump into the demo, I would give you a high-level overview of the solution. So as you know that organizations, they sometimes they can have multiple customer management system, and that can easily happen, if it's a large organization who's acquiring, different companies. That can create a lot of duplicate customer data, which means the same customer can now be present in different systems because they are subscribed to different products. Now, if you have a common MDM system, that problem is already taken care. But if it's not, then you can build your own entity resolution, which is also called identity resolution application, which allows you to look at the customer, the customer properties, the customer behavior, and kind of resolve these customers into a unified customer view. So this is really the first step of building a customer 360-degree. You want to make sure that no customers are duplicate within your database. Each of these customers are resolved into unique identities. And that is what the HopStocks platform allows you to do it. So we are going to show you a little bit of entity resolution as well. Once that is done, then you can start profiling these entities on a periodic basis, which means you are capturing their spending patterns or their behavior in terms of their feedback, what they're providing. So all of these inputs, or the feedback that we receive from customer, we can use as a part of the profiling. So this profiling job can be done on a periodic basis, depending upon weekly, monthly, depending upon how frequently your data is changing. And then once the entities are profiled, then we can run the various type of algorithms. This could be classic AI/ML algorithms, or this could be natural language processing, or it could be even graph algorithms. So what we do is, as a part of the solution, we have taken this data, pushed into Neo4j, which is a graph database, and then we have run algorithms to do clustering, community detection, to generate risk scores, and then these scores can be then used for various aspects. Let's say you want to do a fraud detection, or maybe you want to do a cross-sell, upsell. So there are multiple use cases that you can then leverage upon using Neo4j as a graph engine. Once all these predictions are made, then obviously you want to kind of score these predictions. So every prediction comes with a probability, right? And you may want to club multiple predictions and generate like an overall score so that you can make a decision out of it. So you can do risk scoring, or you can do like, propensity scoring. Different type of scoring can be performed. And then based on the scores, you can put some kind of cutoff and say anything that's above 90%, you may want to take an action upon it, which means naturally you want to generate an alert and then kind of hook up these alerts into some kind of decision-making system. So either you can access these alerts through an API into a downstream system, or you can kick a business process workflow within the same platform, which is HopsWorks, to start making decisions around that. And if you're dealing with something which is like a fraud detection problem, then you can even use the case investigation system that comes as a part of the platform. So we provide you an accelerator, which is an alternate way of building your applications. Traditionally, as I said, if you're using Jupyter notebooks for your app development, then you can certainly use the Python APIs. But if you don't have like strong Python skills, or if you want to really accelerate your journey of building applications without too much of coding, then you can certainly use the accelerator that comes as a part of the HopSpot platform. This is another view how this application is functioning today. So you have all your sources on the left, which are nothing but the operational system where the customer is getting onboarded. It could be a KYC system, or maybe they are doing transactions into your core banking system or your e-commerce system, whatever system you have for doing transactions. So this data is then brought into real time into Neo4j using Apache Kafka. Once the data gets into Neo4j in a real time, then we apply the graph analytics on the top of it. We do entity resolution, we do community detection, we do risk scoring, and we also do feature extraction. So Neo4j is really, it's a graph engine which allows you to run graph analytics and be able to produce features which are then going to be very relevant for your ML modeling. Once these features are created, these features are pushed into Hopsworks. So Hopsworks becomes your centralized feature store, which can extract features out of Neo4j or maybe any other system. So sometimes you can have features coming directly from the operational systems, which can make its way into Hopsworks, or you can have your data going through Neo4j if you want to apply some kind of graph analytics and then generate the features and extract and push into Hopsworks. So this way you are kind of managing all your features in one place. And there are other benefits of managing, feature in a centralized location. One is obviously the consistency of use, where every application sees the feature and in the same way and having the same value, right? It's not that you have a feature with 10 different definitions, because that's what leads to inconsistency and then finally to inaccuracy. So to avoid that, you have the feature store, which will keep things consistent. Also, we have a feature of a time. We have a feature called time travel, which allows you to go back in time to look at the feature values and retrain a model. So what if an auditor comes to you and says that you make this prediction and you have alerted this customer as a fraudulent customer, and now you want to show some kind of proof that what was the data at that given time. So you need to reproduce that scenario, you need the same training data set that was used as a part of your model training a few months ago. And that is what Hopsworks is going to do for you. It allows you to keep different versions of the feature data so that at any given time, you can go back in time and extract the feature values and then kind of retrain the model or do the predictions, right? So it becomes very handy when it comes to auditing and reporting, and it kind of serves as a kind of logging too. If you want to make some real-time decisions when you are generating predictions, you can then use our online store, and then you can kind of block a transaction in real time using the API, which is a transaction blocking API. This could be a purchase happening by a customer on an e-commerce website. This could be a transaction happening in a banking application where where they may detect a fraud and they want to stop the transaction, which could be transfer of money across the borders and things like that. At the end, you can also build dashboards and reports, and then we can kind of incorporate that feedback into the ML model so that when you retrain your model, we have less false positives and we get better alerts out of it, right? So all these modules are kind of available in the accelerator for you to build, not only develop features, but also build train your models, do the inferences, also do the whole model management and the life cycle end to end. Okay, so next time I'm going to get into a demo of the application. But before I do that, maybe Nate, we can take some questions if you see any.
Yeah, Yogesh, what data sources can you bring into Hopsworks? And then also what algorithms can you use on Hopsworks?
Okay, so in terms of the data sources, we have connectors built in, and these data sources can connect, any traditional RDBMS database like MySQL, Postgres, Oracles of the world, and so on. And at the same time, we can also connect to the cloud databases like Snowflake or Athena, wherever your data lake may be. It could be Azure Data Lake as well. Apart from that, we also support reading files. If your data is coming in the form of files, these files can be classic CSV files or TSV files, or if you have something like semi-structured, which is XML or JSON, we can read that as well. Apart from that, we can also read the Parquet files or Avro files. So that pretty much covers, I would say, majority of the file formats and the databases that traditionally are being used in the industry. And from an algorithm perspective, we have around, out of the box, we package all the libraries that are possibly, used in these applications. Within the accelerator, we have 40 plus algorithms which can be used. And if you want to add a new algorithm, you can just install the Python library on the Opsworks platform. And then you can basically start using that algorithm. So adding an algorithm and training a model out of it is not really that tedious. It's a very easy process where you can go to the front end and you can install a library. And if you want to add a new algorithm to the accelerator, that can be done through front end as well. Any other question, Nate?
None at this time. Thank you, Yogesh.
Okay. So I'm going to shift into I'm going to show you a demo of the HubSpot platform now. Let me get the URL. Okay, I think I'm on the screen now. So there are two demos I'm going to do. One is for the HubSpot platform, the core platform, which is basically the ML platform. And then I'm also going to show you the accelerator along with that. So, okay, so I'm logged in here. And now let me get to the accelerator. Okay, so let's look at the core platform first. So what do you see once you log in? You can create different projects. Projects are basically how you want to organize your application, I would say models and artifacts, right? So you can do it by different environments, or you can do it by different projects, or you can just do like project underscore some environment tag. Like in this case, we have created a project called Inferix and it's like a dev environment. So we are calling it underscore dev. So this way you can kind of, it becomes like a workspace where you can manage your users, you can manage your feature data, you can manage your models and so on. Okay. It also acts like a governance thing, right? You don't want everybody to be clubbed into a single workspace because then people can see each other's data. They can start accessing things which are not really applicable to them. So this is going to allow you to segregate all your artifacts and keep them intact within one workspace. You can create multiple users. So this is really a collaborative enterprise platform. You can also integrate with your single sign-on, or you can use the authentication that comes out of the box. Or you can use some of the public APIs like a Google API or Facebook API, log into the platform. Once you get into the platform, then there are certain menus. So you have feature groups. So feature groups are nothing but group of features. I mean, features are variables that you derive, or sometimes they come out of your raw data. So you can have features that you can construct using the raw data, which is like, let's say, customer data, account data, transaction data. But sometimes you might want to compute some aggregated values like, let's say average balances, or maybe what is the max number of transactions I'm performing. So these features can then be calculated using business logic, and then these features can be grouped into feature groups. So feature group is nothing but a group of features, and it depends how you want to organize. Ideally, you would organize by your domains like customer, products, and transactions, and so on, or maybe accounts. So you may use data from multiple tables or the multiple data sets, and then kind of apply the business logic to come up with a feature group. And once the feature group is created, you can then, use this feature group to build your models, basically to train your models and do the inferences. Now we keep a track of all the versions within the feature group. So let's say if I want to search a feature group here for customer, so I have a feature group here, which is having some graph features. These are the features that are extracted out of Neo4j. So there are various features here. It has approximately, I believe, 55 features. So you can see all the feature definitions, what features are available. You can plot the charts if you want to see a histogram, like a statistics. You can configure various things here like provenance, expectation tags. So these are basically, provenance is nothing but the lineage part. Expectations are nothing but like data quality. So as you bring the feature data in, as you bring the data in and you build the features, you want to make sure that your data is all clean, and to define and to check the cleanliness or the health of the data, you can define the rules. So these rules are nothing but the expectations. So there is a framework which is kind of implemented within the platform, which allows you to do these data quality checks. And then if you want to get alerted when if there is any violation, you can do that as well. So you can also create alerts out of it. There is a concept of tags. Tags are nothing but, these things are very handy when you want to, if you are in the middle of the development, you might say this is something which is not ready, or maybe this is in the dev environment. So you can put the phase of your, development as a tag. It can even be tagging the project names and so on. So there are multiple ways you can leverage tags, and then those tags can be used in your CI/CD process or in your search process, or if you want to build something more custom, to start extracting these features. You also get APIs out of the box. So as I was talking before, you can use Python as one of the language to, kind of build your features. And then once your features are built, then you can use the Python APIs to train your model. So to train your model, you need obviously the feature data. And then to get the feature data, you can use the API, which is a sample code that is being shown here to extract the feature data for a specific version. So if you see here, we are extracting version number 3, but if you have, any number of versions, so this is the latest, that's why it says 3. But if you want to switch to version 2, we can do that as well. So there could be metadata differences, there could be data differences and so on. And then just by mentioning your version number 2, you can extract that particular version of the feature group. So feature group is the first thing that you would actually encounter when you're using the platform. Then comes the feature view. So feature views are nothing but you can think like database views, which is nothing but joining certain tables, applying some filter, doing some aggregations. So similarly, a feature view. So let's say you want to build a model which involves features out of customer data and account data, because a customer can have multiple accounts. So you cannot possibly hold the data in one data set. You need to create two data sets. But you may want to build a model which involves both of these. So what you really do is you don't create a third feature group. You just create a feature view where you can join the two customer and the account data using customer ID. And then you can, kind of pull whatever features you're interested in out of both the feature groups and create a view out of it. So that way you're not replicating really the data. It's really the metadata only. And then these feature views can then be used for various purposes for training your model or inferencing or whatever. So feature view is basically like just like a database view, as I mentioned, right? It's a virtual layer. Then you have different storage connectors. These connectors are basically allowing you to connect to your source systems. And then you can create ingestion pipelines. And then also you have the model registry. So what I'm going to do is, like, while I'm showing you the feature group and feature views, I'm also going to take you through the accelerator so that you get an idea that how to use the accelerator to bring in your data and then create the feature groups from the accelerator. So as I mentioned, one of the ways to create feature groups is to Python code. So I showed you the API code. Similarly, I can now use the accelerator to build the features. So I'm logging into, let's say, customer analytics. So over here, I have a data science module. And within data science, I have something called features. So these are the same feature groups that I showed you in the underlying engine, which is the HubSpot. And then these features, I can take a look at it. I can glance through the same metadata that I just showed you under this feature group menu. So this is more of an application development platform, which is a no-code platform, so you can build your apps faster. Here you don't have to write Python code really, because it generates the code and it kind of generates the HubSpot code, which will then store and interact with your HubSpot feature store, right? So as you see here, this particular feature group is stored in the feature store, which is HubSpot. It's a feature group. It's not a feature view. And these are all the features that are available. If you want to take a quick glance of the data, you can just preview the data by clicking this icon. So it's going to connect to the feature store now and bring all the data, that's available as a part of that particular version. So as I mentioned, you can have multiple versions of data available in feature groups. So in this particular case, you have only like one version, but if you had multiple versions, you can choose any particular version and go back in time. So once your features are available, then you can start training the model. So you can define the model. So here I'm having 3 different models. So there is a model for customer segmentation. So I'm using k-means clustering. I'm using 3 different features, the recency, frequency, and monetary. And then you can go and train this model. Once you train the model, then you can look at the results. So first I'm going to train the model. So I'm going to show you what exactly needs to be done when you're training the model. So this is the this is the feature group I'm using, which is customer segmentation features. This is a version on which I'm training my primary key, my row identifier, and all the data that is available in the feature group, I'm mapping to my features, which I've defined in the model. If you would like to see a lineage, like, how these features are derived, I can take a look at it. This is an entity lineage. Similarly, I can do an attribute lineage, right? So lineage is basically, kind of giving you a view that how these features are derived. As you see here, this particular model is using this feature pod, which is nothing but the feature group sitting in the Hopsworks. And if I want to go and take a look at this feature store, I can do that as well. So this is the feature groups which is sitting in Hopsworks, and these are all the features that are available within that particular feature group. Okay. Now let's take a look at the results. So this is a segmentation model, which is created on debit card data. I have 1,000 rows as a sample here. These are all the parameters that I use for training. Feature importance is not available for, is not applicable for k-means clustering, but you can look at the performance metrics. So these are basically the clusters that has been derived using the algorithm and has created a model out of it, right? So this is something which is leveraging the data on the Hopsworks platform. And then we are using these features to train a model out of it. So to begin with these features where all the data was ingested into Neo4j, and that's where we are ingesting all the data, and then we are extracting the features out of it. And those features are then pushed into the Hopsworks, and then they are being trained. And what you're seeing is the result of the training at this point. You can also look at the results if you like in the tabular fashion. So this is a segmentation model. Similarly, as you see, we have created different models. We have a recommendation engine model. We have a customer segmentation. I'm going to quickly show you the graph part, how graph is really playing a role here. I'm going to go to knowledge graph. So this is one of the graphs that we have created for a customer 360-degree view. So this is a graph where you have customer, you have a phone number, which city the customer lives in, what company it works, and sector. We are also working on another similar use case, which is more for marketing. Again, it's related to customer. I'll show you that graph as well, which is much more dense graph, I would say. This particular graph, we are only focused on customer 360-degree and then using it for recommendation engine and for segmenting the customers, right? And then once you build your models, what you can really do is you can build a pipeline where you can stitch everything together into a single pipeline. So as you can see here, we have created a pipeline which has got like 4 different models that are being trained. So first we are ingesting the data, then we are computing, we are performing the entity resolution, which is nothing but the resolving the customer, as you can see here. Once the entity resolution is done, then we are training the models, 4 different models. And then once those are done, we are evaluating and then kind of generating alerts out of it. So what's the step after, like, generating the predictions? Once the predictions are made, then obviously you want to take some action upon it, but you can only take an action when you get alerted about something, right? So there has to be some kind of alerting engine which allows you to consume these predictions and then make make a recommendation or send an offer. It could result into anything depending upon what you're looking for. It could even be an alert for a fraudulent case, and you may want to stop the transaction in that particular case. So let's look at the alert engine now, how the alert engine is configured. So you can basically create a business rule which looks into your customer data, and then you can define some kind of threshold. Let's say here is a threshold of 10, but you can keep a higher threshold. Once the threshold is set, it's going to generate the alerts. So now I can look at the alerts. So these are the alert details. These are the customer details. I can see what rules were used under the hood. I can also look at the Neo4j graph. So I have notes and documents. You can attach documents to this. And then you have workflow. So workflow is something which is, let me just switch to a different application here. Okay. So let me show you the workflow piece. So we have generated the alerts here. Okay, this is the customer alerts. Look at the rules. Then I can go to the link analysis where I can look at the customer. So as you can see here, we have the customer and we have all the surrounding nodes and edges. So this particular customer is using this product. This is the email ID, what's the role, um, the flag, phone number, country. So it's a very holistic model or a comprehensive model that kind of takes care of all your data elements and all your entities. And if you want to take a look at the details of it, I can just click on the product and I can say, show me the details. So whatever is the product category, it's going to show you that. So this becomes very handy because now we are really bringing together the power of the Neo4j graph database and the HopsWorks platform, which is the ML platform, all into a single, accelerator. So similarly, you can put your notes here, documents here. Now the workflow, I wanted to describe it. So what happens is, imagine you have made some recommendations, right? So using recommendation engine, you can generate recommendations. And then out of those recommendations, you're going to generate the offers. So we create alerts out of each recommendation, and then each recommendation or an alert translates into an offer. So we get the alert details, and then based on the alert information, we try to extract the offer information, like what offer you want to send. Once the offer information is extracted from your database, then we can send the offer, which is basically mailing the offer. And once the offer is sent, if you want to resend the offer for whatever purpose, or maybe the customer did not open the email, or maybe they're calling the call center and saying that, I didn't receive the email. So what the customer marketing person can do is they can just push the button and take an action and resend the offer. So this is like a sample workflow, which is typically used for any kind of recommendation engine, but there could be various workflow within your application depending on the use case. And the accelerator is going to allow you to build these applications, right? It's going to allow you to build different workflows, different models, and different dashboards and reports based on your use case. And then if you're sending any notification, we can also send notifications if you configure any. In this particular one, we haven't configured any notifications, but you can kind of configure a notification that when an alert is generated, it's going to inform you about the same. So this is alert generation part. Now, the final piece I want to show you is the visualization. So we have few dashboards. So let me get into the dashboard. I'm going to go back to the customer analytics. So we have a customer 360-degree dashboard here. I'm going to select the customer and do a search upon it. So what we have done is now we have created a visualization, a dashboard, which contains different types of visualization. And I'll explain you what exactly is happening behind the scene. So in this particular case, in the accelerator, it allows you to build these dashboards through drag and drop. So I can show images, which is the photos that are sitting on the file system. I can take some data out of my RDBMS or maybe my data lake and show those details. I may be doing some prediction as a part of my ML platform, and I can extract those recommendations and kind of display it here. I can also do a sentiment analysis of all the comments that have been passed, and then based on that, I can generate a sentiment score. So what we are doing really is, with the help of the accelerator, we are bringing together all the information in one place. It can connect to your graph engine, it can connect to the HopsWorks platform, and it can also connect to your RDBMS system where your raw data is sitting. Okay, so this is the data visualization part. And now similarly, I'll show you on the model part. So what we had done was, when we created the model, when we train the model, what happens really is we store the model into the HopsWorks registry. So this is the model that is already stored in the HopsWorks. So I can click here. Again, even the model, just like the feature groups, the models are also versioned within HopsWorks. So you can jump to the latest version, or you can get to, if you have multiple version, then you can go to that specific version of the model. If there are any metrics, it's going to show you for that model what metrics are available depending upon the type of model. Not every model we have like metrics to show, but if you are doing a classification metric, then we show you like the confusion metrics and few other accuracy metrics. So again, I can go to the metrics. In this case, there's no metrics for this, but let me pick something else. If I have this, and I can look at a particular version as well. So let's say if I choose version 1, I can go to version 1, but there's no metrics for this particular one. So this is basically keeping an inventory of all the models and every version that is around the model. So the next step, once you create the model, is really the deployment part, right? So you want to basically deploy this model in production. So we have the deployment screen, which allows you to create a new deployment, which allows you to pick your model, pick a particular version, and do a deployment. Once you do the deployment of the model out of the model registry, then you can connect through an API, which allows you to do predictions in real time. Also, you can run this model instead of deploying. Once you deploy, you can run the model as a batch, which allows you to do predictions on a bulk of data instead of like one record at a time. So depending on your use case, either you can do like real-time predictions or you can do batch predictions, however, whatever the need of your application may be. Okay. So now the last thing I wanted to show you was the entity resolution. So I'm in the market customer analytics. Okay. So just to give you an idea, what you can do is you can also create entity resolution rules, which are going to run in Neo4j graph engine. So you can point to your data, you can decide like what's your entity. So in this particular case, I'm trying to resolve customer, so I'm going to choose customer. You can do filtering on the data. Maybe you don't want to read all the data, right? So entity resolution plays a really vital role when it comes to the customer 360-degree use case, because as I said, you don't want to send the same offer to the same guy 2 or 3 times. You want to make sure that your customer is identified uniquely so that every dollar you're spending in terms of marketing is worth, you don't want to, because the more number of times you send the same offer, you're going to incur a cost, and you're also going to annoy and have a bad customer experience. So all of this can be avoided by having an entity resolution engine in play, which is available on the HopsWorks platform. It's out of the box. You can configure it and you can run it, and it's going to leverage the Neo4j graph along with the HopsWorks to make it happen for you. You can put the blocking conditions. These blocking conditions are nothing but, you want to, when you're comparing this data, you want to compare within a certain region or within a certain country, because you may not find it worth comparing data across regions or across countries. So you can do that as well. You can even decide by product. You can pick whatever grouping idea you can think of. It's a configurable idea, so you can choose whatever you want, and you can run different experiments and see which one really resolves the best entities for you. Similarly, you have like, you can create different matching groups like first name, last name, and phone. You can compare different things, and then you can use the distance function. These are like string functions, which allows you to compare two strings like first name and the last name. And it's going to compare like every customer that's out there with every other customer, but it's going to do at scale because we are using Neo4j as a graph engine, which really scales well, right? It can scale to billions of data points. And this can then also be utilized in a real-time mode. So you can do a one-time historical execution of entity resolution, and then going forward, you can do on an incremental data. But what if you want to do something more in real time, which means when you're doing like a KYC application or onboarding a customer, you want to call through an API and make sure that you're not onboarding the customer as a new customer if the customer already exists in a system. You want to rather resolve to an existing customer if there is a resolution, and kind of recommend back to the system saying that this customer looks to be a similar customer to something that exists in your platform. And then the onboarding guy, or the onboarding person can kind of make a decision whether they want to link to an existing customer data or they want to create a new customer record for the customer which is being served over there. And then finally, we can visualize the results of the entity resolution. So let's take a look. The rules are already executed at this point. So if you see here, again, this is fake data. This is mocked up data. I have 1,000 entities, which is nothing but 1,000 customers. And they are kind of uniquely derived into like 34 unique entities. Ideally, you may resolve like, 98% of your data may be unique, maybe 2 or 3% is duplicate. So it's going to kind of drive that upon that. So I can right click and I can say like, I want to basically get into this cluster. So what we do is we run the graph algorithms in Neo4j to resolve these entities. And then once the entities are resolved, they get associated to a unique ID, which is also called like a component ID. So if I want to analyze a particular customer, I can choose a customer ID from here, and I can see to how many other customers this customer is being resolved. How many other customers is kind of, the system believes that it's a match. So as you can see, this particular customer is kind of matching with various other customer, and then there are different thresholds. So a 75% match may not be significant for you. You might say, I won't only care about matches which are like 95 and above. So I can look for something. So if you see at this particular comparison, the matching is like almost 100%. I can say, show me the details. I can look at the details and see what exactly has happened as a part of the matching group, right? So I had two groups where I'm comparing first name and last name. My first name is quite different, but my last names are kind of matching. That's why the score is 1, which is like 100%. But then I'm giving a 50% weight to it, which is kind of then becoming a score of zero point 0.5, right? So this kind of scoring can go from like 0 to 100 or 0 to 1. It just depends. In this particular case, we have configured the system to generate a score between 0 and 1. So the overall score is 0.63, which means 63%, there is a 63% match. If you look at the other group, the last names are completely matching. The phone numbers are also matching. So there is a high probability that we can kind of rely on this group, which is saying that it's 100% sure that these two guys are the same guys. And now and the front office system can kind of make a decision that instead of creating a new customer record, they can they can kind of resolve or connect to this particular customer. So this kind of helps you creates less mess as you go along, but you can also clean up existing duplicate data using the entity resolution engine to run as a batch, right? So these are all the modules that are available in the low-code platform that are going to allow you to bring in your data, perform the calculation, define the features, do the training of the model, do the inferences, and so on, right? I'm going to take a brief pause here, Nate, if there are any questions at this point.
Yeah, Yogesh, about how long does it take to implement maybe your first use case with HopsWorks?
Yeah, I mean, like installing the platform and configuring is let's say like, a couple of days, and then you can, once you have access to your data, because most of the times where customer really lose time is in terms of, looking for the data, which is not in existence within the HopsWorks. But once you have access to your data, the connectors are inbuilt, you can connect to the data, build your features, but literally you can build a model in like 2 to 3 weeks if you have a good understanding of the data, right? Because all the libraries are already installed, and I would highly recommend that you use the accelerator to accelerate your process, because anything that you're building in accelerator is done in a very consistent manner across all users, all applications. And then it makes your life easy in terms of like running different experiments, um, and then kind of exporting that application to a higher environment when your POC is done. So, I mean, the answer is really like 2 to 3 weeks. That's what we have seen, I would say, provided the data is available.
Thank you, Yogesh. That's all the questions at this point.
Okay, so I'm going to switch back to the presentation, pretty much on the last slide here. Okay, just to conclude today's webinar, so I hope you got a good idea about what a feature store or an ML platform, how can it change your application development journey in terms of building AI application. Um, so at the end of the day, we just want to make sure that, the platform really allows you to uh, generate value for your business users. And the only way to make that happen is to kind of, build your applications efficiently, consistently, and make sure that there are no gaps, and that is possible through the platform that we are offering here, right? We are also making sure you're getting the best performance out of the box. That way, you're not like doing a technical job of fixing the libraries or trying to match to a lot of experiments, because you can end up losing a lot of time trying to stitch together such a platform. I mean, it's not impossible, but it takes a lot of time to build this. So we have invested like, many, many years here to like build a platform of this type, which allows you to, and we have brought the best of the libraries into the platform, which gives you that kind of scale. So we use components within the platform, which allows you to scale to, millions of record in like milliseconds. We can make predictions literally in milliseconds, right? So having a platform which can offer you that kind of scale and speed is really, really important, to generate a better value for your end customer or end users. And also, the whole platform, the low code development, right? So you get the low code development tool, which allows you to build your applications without writing too much of code. And then you can manage like multiple applications. You don't have to build like reinvent the wheel every time you're building a new application. Instead, you can use the same accelerator and provide access to like multiple users to collaborate, to build more and more apps, right? And then once you build your apps, you have these API layer, which allows you to do integration. So all of this is kind of available out of the box. The only thing you need to do is really bring in your data and then use the accelerator or use the Python APIs to build your features, train your model, and inference it. But everything that's required in terms of the bells and whistles are already available out of the box. And that is the reason you are able to build your models pretty quickly as compared to the traditional way, right? So that's pretty much for today's webinar. Nate, I'll hand it over back to you.
Hey, Yogesh, thank you as always. What a terrific presentation on Customer 360 today. If anybody needs any additional information, you can reach out to us on our website at hopsworks.ai, or you can reach out to me directly at nathan.greenhut@hopsworks.ai. Looking forward to chatting with you, and thank you for joining our webinar on ML-driven Customer 360 using Neo4j features. Thanks all.